So good morning students. So today we are going to discuss the next exercise 3.6 lecture second. The today's topic is equation reducible to a pair of linear equations. So this time we will not be given pair of linear equations, right? What we are studying in this throughout the chapter, pair of linear equations in two variable. So this time we will be given the different types of equation which is not the linear equations. Okay, so what we have to do, we have to reducible, that we have to reduce the given equations into a pair of linear equations. After that we will solve it. So there is one step, okay, more which is required to be done in the questions. So let me take the question number first part. The equations are given 1 by 2x plus 1 by 2y equals to 2 and same as the another equations given. So what we see here, we find that x and y in both of the equation, it is coming in denominator, right? But what's the pair of linear equations standard form says? It should be ax plus by plus c equals to 0. Okay, so here a is what? Constant. So constant is 1 by 2, but x is coming in denominator. It means the equation is not the pair of linear equations. So to reduce this, what we will do? So the process is, let we assume 1 by x, actually this is 1 by x, so we are assuming 1 by x is equals to, with a different variable, let's we are taking you may take any variable, and 1 by y equals to v, and let us take combinedly these equations as free. Now substitute 1 by x as u, 1 by y as v in equation first and second. So from equation first we have 1 by 2 as it is, because this is the constant, okay, and this 1 by x is also there, so we will write 1 by 2 u, and u will be written where? In numerator, make sure, plus similarly 1 by 3 as it is, and this 1 upon y is coming, so 1 upon y we are writing into v equals to 2, right? So this time the equation becomes a pair of linear equations as well as linear equation of degree 1, because linear means degree 1. So we can see u and v coming in numerator, and it is what? Definitely a linear equation. So now we can further simplify taking LCM. So this is 3u plus 2v equals to 2, and by cross multiplication we will get 3u plus 2v equals to 2 6 12. Equation number 4, right? So this has come from equation first. See, from equation first we have obtained equation 4. Now similarly from equation second, this can also be expressed in a pair of linear equation form, that is 1 by 3x. So 1 by x is replacing by u plus 1 by 2 into 1 upon y, that is v equals to 13 by 6. Now again take LCM. So 2u plus 3v upon 6 equals to 13 by 6. Cancel out by cross multiplication. I have cancelled directly. So you will show due to cross multiplying, right, this side or this side, equals to 13, and this time this is equation 5. So now we clearly see that we have got the equations which are given 1 and 2 not in the linear equation form. Now the equation has been reduced in a pair of linear equation, that is equation 4 and 5 is linear equation, okay, with variable u and v. So now we have to solve equation 4 and 5 using elimination method, okay, substitution method or cross multiplication method. You may apply any methods and get u and v. So we have to solve these equations for u and v, right? As usual we have solved earlier. Now after getting the value of u and v, what is the next step? After getting u and v, substitute in equation 3 in place of u and v, and just by doing cross multiplication we will get the value of x and y. Okay, so first of all solve these equations for u and v by any algebraic method. After getting u and v, substitute the value of u and v here in equation third at the place of u and v, then get x and y. Okay, so in the question number first there are 8 parts, and in each and every part we have to follow this thing, right? So let's take the second part, that how to reduce. So this time we are learning how to reduce the given equation which is not linear. So this time under root coming. Okay, so we should not be afraid of this symbol. Okay, under root means we will usually solve it as previously we have solved previous part. Only one change is to be made. See what change? So if you compare this part with the first part, so you find only under root x, under root y is coming. Okay, and the constant may be in fraction 2 or 3 or whatever it is, it doesn't matter. So again this time we will assume we wish to reduce this equation into pair of linear equations. So 1 by root x this time is taken as u, and 1 by under root y equals to v. Equation third together, right? Now from equation first, what we have to do? We have to replace u and v. Okay, substitute u and v where? At the place of 1 by root x and 1 by root y. So what we will get? 2 as it is into 1 by root x. So 1 by root x becomes u. So 2u plus 3v equals to 2, right? So this is equation number 4, and hence from second we also reduce this. This is 4 and u, right? 4 and u minus 9v equals to minus 1. Equation number 5. Now we have to use any method. So I suggested you should use elimination method. So for elimination, if you want to cancel u, we can multiply this equation by 2 throughout, because 2 and 2 becomes 4, right? And here 6 and here 4. Then subtract the equation, get the value of u and v. So we already discussed about this elimination method, right? So if you further have doubt, you will ask your doubt, right? So only one step that you have to reduce the given equation. Now same as in third part, 4 by x plus 3y. Okay, I write one equation, 4 by x. So with y there is no problem because degree is 1 only. Okay, and here is x coming in denominator. So there is only problem that we have to reduce this 1 by x equals to u or any variable, and y as it is. Okay, so this is second. So from first and second, 4 and 1 by x becomes u. So 4u plus 3y equals to 14. Equation number third. Okay, for y there is no problem because it is already in standard form. And similarly the second equation, 3 by x minus 4y. So 3 by x means 3u minus 4y equals to 23. Equation number 4. So again we have to use elimination method. So multiply this equation. If you want to cancel u, multiply this equation by 3 and this equation by 4. Why? Because 3 4s are 12 and 4 3s are 12. We have to make them equal, and after that subtract both the equations. So u and u cancel out. You will get the value of y directly, and after getting y, substitute in any equation. Okay, what the elimination method we have already done. Okay. So you need to practice elimination method, substitution method. If you do that, you are able to solve. Okay, let's see one more part. In fourth, I am writing what we have to assume. Let, I am giving you a hint. 1 by x minus 1 as u and 1 upon y minus 2 equals to v. So now you must be thinking that here why we are not taking 1 by x 1 by y, because here 5 upon x minus 1 is given, 5 upon x minus 1. So x minus 1 cannot be separated. These are different terms. X minus 1 are what? Different terms. So that's why we have to assume 1 upon x minus 1 completely, because there is minus sign. Even if there is plus sign, so we have to assume. And in part first and second, it is coming in product. So whenever there is product, we will take independently 1 by x as u or 1 by y as y if x and y are independently. That is in product. But here in this part x minus 1, so here x or 1 cannot be separated. So we have to assume whole term as u and y. So let's write from the books you will write the equation first and second. So first implies 5u after replacing this by u and v plus v equals to 2. Okay, so copy equation first and second from the book, first and second, and you may take this is as third and this one as 4, and this is due to equation second implies second reduced as 6 upon x minus 1. So this is 6u minus 3v equals to 1. Equation becomes 5. So now again linear equation 2 variable. So you can simplify. Now I am taking fifth part. This is little different as compared to till fourth part. You can also see this time the equation is given like this. Okay. So what we will do? This is the equation first. So this time we separate the terms like this. And this xy is being separated for 7x as well as 2y like this. Okay. So now we see x or x cancel, y or y cancel. So we'll get 7 upon y. 7 upon y minus 2 upon x equals to 5. Okay. So this is your equation second. Now similarly the second another equation is 8x plus 7y upon xy equals to 15. This is equation third. So we can reduce also as previously, separating the terms. Equals to 15. So x or x cancel, y or y. 8 upon y plus 7 upon x equals to 15. This is equation number 4. So now we clearly see equation second. We have to solve equation this second and fourth. And equation second and fourth is really becoming as equation first part. Question number first part. So after this we have to proceed 1 upon y as u or 1 by x as v. That we have already done in first part. So assume 1 by y as u and 1 by x as v. Now then the same first part would be repeated. So I hope you understood these all types, right? So ask your doubts if you have, and the next videos we will be discussing the remaining questions. Thank you very much.